Today we are going to see about atomic absorption spectroscopy. Slide தெரியுதாப்பா?
தெரியுது சார்.
ஸ்லைடு தெரியுதா உங்களுக்கு?
தெரியுது.
ஸ்லைடு எங்க okay. Atomic absorption spectroscopy. It is a very common method of spectroscopy which is used for detecting the metals and metallites in the sample materials. Okay. Next. It is a spectroscopy which deals about the spectroanalytical procedure for the quantitative determination of chemical elements, which is using the absorption of optical radiation by free atoms in the gaseous state. Then atomic absorption spectroscopy is mainly based upon the absorption of light by metallic ions. It is very reliable and simple to use. It can analyze all the 62 elements. Okay, 62 elements வரைக்கும் வந்து உங்களுக்கு இந்த atomic absorption spectroscopy-ல detecting பண்ண முடியும். ஓகேவா? It also measures the concentration of metals in the sample. This is the basic principle of free atoms which produced in a atomizer can absorb the radiation at specific frequency. Atomic absorption spectroscopy quantifies the absorption of non-state atoms in the gaseous state. The atoms which absorb ultraviolet or visible light and make transition to higher electronic energy levels. The analyte concentration is determined from the amount of absorption. In analytical instrumentation, this technique is used for determining the concentration of a particular element in a sample to be analyzed. It is abbreviated as AAS. It can be used to determine the elements in a solution or directly in solid sample via the electrothermal vaporization, and it is used in biophysics, archaeology, toxicology, pharmacy departments. Okay, no. Atomic absorption spectroscopy was first analytical technique underlying the principles in the 19th century by the scientist Robert William and Robert Kitsoff. Okay, wow. Both are the professors at the University of Heidelberg, Germany. It quantifies the absorption of ground state atom in the gaseous state also. The atoms absorb ultraviolet and visible light and make the transition to higher electronic energy levels. The analytic concentration is determined from the amount of absorption. Okay, wow. There are four or five methods in analytical atomic absorption spectroscopy: hollow cathode lamp, nebulizer, atomizer, monochromator, detector, and finally recorder. Okay, wow. Readout device. This is the schematic diagram of the atomic absorption spectroscopy. First we introduce the hollow cathode lamp, and then monochromator, and a detector, nebulizer. Okay, wow. The schematic diagram பார்த்தாலே உங்களுக்கு எல்லாம் தெரியும். ஓகேவா? லைட் சோர்ஸ் வந்து ஹாலோ கேத்தோட் lamp யூஸ் பண்ணிருப்பாங்க. ஓகேவா? ஹாலோ கேத்தோட் lamp are the most common radiation source in atomic absorption spectroscopy. It contains the tungsten element and hollow cylindrical cathode made of the element to be determined. These are sealed in a gas tube filled with an inert gas, that is neon or argon. You know, each element has its own unique lamp which must be used for that analysis. And the picture பார்த்துக்கோங்க. Quartz window, இது quartz window, anode cathode இதுன்னு பார்த்துக்கோங்க. ஓகேவா? இதான் வந்து hollow cathode lamp. ஓகேவா? Nebulizer. nebulizer function என்னன்னா it sucks up the liquid samples at controlled rate. It create a fine aerosol spray for introduction into the flame, and it mix the aerosol and fuel and oxygen thoroughly for the introduction to flame. Okay, atomizer. Next is atomizer. Elements to be analyzed needs to be in atomic state. Okay, atomization is separation of particles into individual molecules and breaking molecules into atoms. This is done by exposing the analyte to high temperatures in a flame or graphite furnace. There are two types of atomizers: flame atomizer and graphite tube atomizer. Okay, flame atomizer. To create flame, we need to mix an oxidant gas and a fuel gas. In most of the cases, air acetylene flame or nitrous oxide acetylene flame is used. Liquid or dissolved samples are typically used with flame atomizer. Okay, next வந்து graphite tube atomizer. Graphite tube atomizer na வந்து graphite use பண்ணி பண்ணுவாங்க. ஓகேவா? Graphite tube atomizer uses a graphite coated furnace to vaporize the sample. Here the samples are deposited in a small graphite coated tube which can be heated to vaporize and then atomize the analyte. The graphite tubes are heated with high current power supply. Monochromator. Monochromator is an optical device that transmits the mechanically selectable narrow band of wavelength or light or other radiation chosen from the wider range of wavelength available at the input. Okay, wow. It is very important part in this kind of spectroscopy. It is used to separate out all the thousands of lines into a single line. Okay, wow. Monochromator is used to select the specific wavelength of light which is absorbed by the sample and to exclude other wavelength. Okay, wow. The name the monochromator name is from the Greek word mono, single. Okay, wow. And chromo means color. Okay, wow. Prefix mono on the single. It is a Greek word, and chroma indicates color. Color na. Okay, wow. Although there are a number of useful ways to select a narrow band of wavelength in the visible range is perceived as a pure color. There are as many ways to easily select any wavelength band from a wide range. Monochromator is used to select the specific wavelength of light which is absorbed by the sample for the spectroscopy. The selection of the specific light allows the determination of selected element in the presence of others. Detector. The light selected by the monochromator is directed into the detector, that is typically a photomultiplier tube whose function is to convert the light signal into an electrical signal proportional to the light intensity. The processing of electric signal is fulfilled by the signal amplifier. The signal could be displayed out for readout device and then to the data station for printout by the requested format. Okay, wow. Detector is nothing but the measurement device which is used for our printout purpose. Okay, wow. Then calibration curve. Calibration curve is used to determine the unknown concentration of any element in the solution. The instrument is calibrated using several solutions of known concentration. The absorbance of each known solution is measured and then calibration curve of concentration versus absorption is plotted. The sample solution is fed into the instrument and the absorbance of the element in the solution is measured. The unknown concentration of the element is then calculated from the calibration curve. These are the applications. It is used in environmental studies, drinking water, ocean water, சாயில், ஃபுட் இண்டஸ்ட்ரி, பார்மசூட்டிக்கல் இண்டஸ்ட்ரியில் யூஸ் பண்ணுறாங்க. ஓகேவா?